Good afternoon, everyone. I hope you can hear me well, both online and in person. And first and foremost, I would like to thank everybody, especially David and the organizing committee for this opportunity to share my insights and thoughts on how we use machine learning in the wealth management space in Scotiabank. To say a little bit about myself, how did I end up in this space? So my journey to the space is very non-linear, to say the least. So I started from an astronomy and astrophysics background, where I was dealing mainly with large data sets, but most image and time series-based data sets, developing machine learning algorithms and generic algorithms in that space, where then I moved on to a postdoc and a data archivist with our Canadian Space Agency, working with our own satellite imageries and satellite data. And then I had a jump over to the startup space. Who hasn't put their foot in there, I guess. So where we were looking at helping new immigrants preserve their memories using voice models and memory space, images as well, videos. And then finally, I end up in the financial sector as a pricing analyst, where I mostly look at structured data at this point in time. So as you can see, throughout this journey, my one constant companion has been data. And so today, my talk is going to be focused on how we look at the data or the data perspective in the wealth management space, and how machine learning models are done within Scotiabank for the wealth management. And so I'm not going to be talking about data as such, but just a perspective. So currently, I work with supporting the various different product lines in the global wealth management space. I know a lot of the talks the past 3 days have been on the portfolio level. So I'm going to take you really a big step back and ask you to look at it from a product perspective, product level, and see how we can use the expertise that we have in this space, and how we can apply quantitative finance to the space. So with that in mind, I want to start with how we integrate with the business. So I'm a data scientist in a basic way. So I'm more like the technological speaker for the business, and act as a bridge between the business speak and the techno speak, essentially, in the organization. So one of the main goals of what we are looking at is, how can we achieve, how can we have our client have the best experience possible with all the technology that is available to us, and the analytics that we can do with these data sets that we have. So in a traditional sense, wealth management is a very conservative business line. So I would say, if you had asked me about a few years back, just before COVID hit, how much will analytics and technology change drive the change in this space, I would say it could take a really long time. But thankfully, I think on the other side, the socioeconomic factors have driven this change at a much faster rate in this sector as well. So to that end, now we have a lot of our business partners wanting to do data-driven decision-making processes, wanting to implement those processes. And they have started to trust this machine learning models that we develop, and these processes that we are developing. So at the end of the talk, I would like to leave with this question. So where is this future going in? And where are we seeing ourselves in this space in the next few years down the line, maybe by 2030? There are quite a few articles, white papers that have been published in this space. Where do we see yourself in 2030, the bank of the future? So that's where I want to leave you all with at the end of the day. So with that in mind, I am sure this is a workflow that a lot of us are familiar with, the CRISP workflow, which can be used for both machine learning, data mining, various other analytical processes. So I'm going to walk you through this process that we have, but from a perspective of some of the models that we have developed in the organization, which are, I'm going to be specifically talking about the referral models where we want to increase the client growth opportunities. So the first point, when we all talk about client growth opportunities, okay, so we have a client coming in, but we have so many different products in the bank. Which product is the good fit for a client? At the same time, which product can get the maximum benefit for the client as well? So you have to look into both perspectives. So to give an example, say a client is of a median age of 50 years with a really good investment knowledge and investment assets. So which is a good product for him? Which one would you as an advisor recommend? Can a machine learning model help in the advisor making the right judgment call? And therefore it becomes an optimization problem as well. So some of the products I have listed out are what we have in the bank on the wealth management space in Scotiabank specifically. So if you look at iTrade, for example, it is a completely managed platform. You don't need any advisors. So this person will fit into that very easily, because if you have the investment knowledge that you have for the median age of 50 in the demographics profile, they have some investment knowledge in general. So you can just go and start doing your investments in there. But at the same time, if you look at it from where they are in their life cycle, they could be in a really, really tough spot where they are managing a lot of different aspects of their life. So they might need the assistance of an investment advisor to manage their portfolio. But so which is the best product again? It could be Scotiabank Cloud or Private Investment Council. What's the difference? How much the client wants to invest their time and energy into managing those portfolios. So, but at the same time, this person is a really high net worth client. We have the private banking, which means it is completely managed and you have your own banker to do your day-to-day activities as well. So you have a single client profile and you have multiple products which would fit for the client and would help their financial journey as well. So the two important questions that we always as data scientists, we have to keep in mind: who's a good customer for this particular product and what product will help this customer in their financial journey. So with this in mind is how we can actually define the problem statement even before we go into data or machine learning or what modeling or whatnot. So understanding this, coming to a consensus between the business and the technologist or the analyst in the bank is a very important part of this process, this flow that we have developed in the bank. So this, at the end of the day, becomes a personalization and a referral problem if you are looking at both sides of the coin. So is that all? So I know which product, or I can do an optimization between the different product lines and customer behaviors, and I can say, okay, this is the best product for the client. Not enough, actually, even before we go into the actual data part of it. So these are high net worth clients we are talking about. So if I'm looking from a client perspective, which is the right channel, or what is the frequency that I would have to contact this client? We have to think about this before we even start with the problem, because based on these factors is how we would go and get our historical data set as well. Say, for example, this is a problem that we are going to be talking to individual clients on a one-to-one basis, then I would have to have in my training data set data defining in history clients' interaction with the advisors. If it is an email campaign, I need to have that email click rate and whatnot, their email interactions. But if it's more like a webcast, then even if I don't have all this data, I can still go and make my model. So I have to make a decision, a conscious decision with my stakeholders, even before I start the problem, into defining how these is going to affect my problem statement. And how will the results of this model be used? Again, I come back to the same point. And how am I going to measure the results actually? Am I just going to say, okay, I got like 100 people in this webcast, so is that my measure, or am I going to measure it in terms of revenue? If I'm going to measure it in terms of revenue, then I need to make sure that my input features for the model will have that information already in there about the client's behavioral analysis and the balance behaviors as well. And most importantly, a lot of times, at least in the wealth management space, we don't have, as a data scientist or a machine learning practitioner, we don't have the one-to-one interaction with the client. And therefore, the feedback that comes from the client has to be passed on through our stakeholders in more than one space. And that feedback is very, very important for us if we want to continue usage of this model in the space as well. If the investment advisor is saying, okay, I don't want to use this product, it's making my life more complicated rather than easy, at the end of the day, this model will not be used. So we need to have a way of getting that feedback loop built into our process flow before we start the model itself. So with that all in mind, then we go on to the data part of it, which is always the fun part, because you're going to get your hands dirty and you're going to get to see the data there. But I would not say about, I would say however, in this point. As I mentioned, when we are defining the problem statement, okay, so this machine learning model leads will be used, say, for an email marketing campaign. So I would have to look into making sure that I have data consistently available for my training set as well as for my future prediction set about how this marketing campaign is deployed, how the results of the marketing campaign are going to come in, and how am I going to access that data in the future. Because as we all know, in big organizations like Scotiabank, a lot of our systems are legacy systems, and therefore the data is much siloed as well. So getting access and continuous access is one of the key factors in determining how successful your implementation of a machine learning model is going to be in this entire process. And another thing, again, it's come back to the siloed data sets, is complexity of the data itself. Because we are talking about high net worth clients, there are a lot of policy constraints that we have to think about. So one of them is the consent to share. So to give the example, Quebec last year, end of last year, implemented the bill. I believe it is Bill 16. One of the important factors there is exception to consent. So there are certain exceptions to consent, which is part of that bill. I don't know if it has come to application yet, but when it comes there, it is something we have to consider for clients within the Quebec region alone, even though you're making a machine learning model for the entire Canada or for any other region. So, so that is something we are as an organization thinking about going into the future. And to that end, one major step that we do in the organization is how are we going to use the data? How are we going to consider this machine learning problem in the space from an ethical perspective? We have a set of policies and rules developed within the organization called the Ethics Assistant tool. And we are one of the first organizations to put this into practice for all machine learning models in the organization so that we are regulatory compliant. Even before it became, or it will become absolutely necessary. So one of the key aspects of this tool is to look at the various bias and fairness features that would go as input into the model. So the quantitative analysis that is done as part of this ethics assistant tool process is twofold. So we have to go through this process before we start the model. When we have all the data, we develop the model, and we have to go through this process after that as well, just to make sure that we are treating the prediction set and the future prediction set the same way that we are treating the training and the test sets as well, so that we are completely ethically compliant throughout our machine learning process. So this makes sure that we are not going to be using bias features does not mean that. If we use those features, we are treating them or we are unbiasing them within our data set, within our training and the prediction set. Or we have a really good business reasoning for using it that way. So with that in mind, this is my favorite part of the entire process because I have crossed all the checkbox of just before doing the modeling part of it, where I can actually get to play with my data sets. So I just want to share a couple of instances where we were and how things changed. I know that a lot of us use averages when we are doing feature engineering, especially if you're looking at clients' historical behavior in terms of their balances or their products. And we had models which were doing that and which were being put into production and used by our business stakeholders. And then we had the COVID hit. And we started seeing that our models are not performing the way it should perform. What could be the reason? And one of the things that kept coming back was averages. We are making this inherent assumption that the customer behavior is consistent. And due to the economical conditions, when COVID hit, the customer behavior was not consistent. It was behaving counterintuitively. So we had to look into ways of capturing this behavior of the customer, but at the same time, we need to be able to explain it to the business who is going to be using it. So at all points in time, at all points of this machine learning flow, we have to look into how do we explain what we do to the business and how can we get their buy-in. So one of the, from my previous life, I have, when you're dealing with time series, extremely fluctuating time series, there are various methods. I think today morning we saw the downturn and whatnot. And IQR is a really good measure of customer behavior over a long period of time, especially when you have varying behavior. But translating this, when that particular feature comes as the top feature, when you are explaining your model to the business, was a bit trickier part of it. So the way you have to define your features will change a little bit as to how can you explain this to the business at the end of the day. And we are looking at client data here, which means somebody would have an actual product and they would have a zero balance. But that would also be clients who did not have the product at all. So is it good way to actually treat those values as zero? Are zeros really mean that they have zero balance or they have no product? So the way you can actually treat those values depend on what is your final problem that you're trying to solve. If you are, say, for example, looking at a regression model at the end of the day, trying to predict the dollar amounts, then you might actually use zero as zero. Whereas if you're looking at whether the client is going to actually have the product, buy into the product, then you would treat it as actually a null value rather than a zero value, because the way the output can be explained at the end of the day will depend on what your initial objective is going to be like. So once we sort of get a handle on the different features that we can do with this data set and make sure that our pipelines are good, then we move on to algorithms and actual machine learning part of it. Surprisingly, if I look at the entire machine learning flow, end to end, from the first point of contact to final deployment in a marketing campaign, the amount of time that you actually spend in this phase is very small. The amount of time that you spend in all the other phases are much, much longer. And also the amount of experimentation that you can do is much limited in a regulated industry. So so always we keep explainability at the top more than having a good metric. So with that in mind, a lot of times within the organization, we end up using, even though we might play with autoencoders and whatnot, for structured numerical data sets, we end up using tree-based or gradient boosting algorithms. And that is understood by the stakeholders as well when we go and present this as a potential way for them to enhance their businesses. They are understanding these algorithms better than if I go and say, okay, I used autoencoder and I used reinforcement learning. They're like, okay, what are you talking about? For this particular problem, of course, if you're looking at text-based or image-based problems, that is a different space, but I'm talking specifically about referral problems here. So with that in mind, we usually end up using with XGBoost, which is an industry well-recognized, well-tested out in the organization algorithm. We make some changes to that, but not very much so. Sorry.
Yeah. Sorry. Yeah. So when you're talking about explainability, right? Are you talking about explainability to your stakeholders or being able to explain the results that the model spits out?
Being able to explain the results to my stakeholders. So a completely non-technical audience.
But like explaining the model and how it works, or being like telling them, yeah, the results are X because.
Exactly. Yeah.
Okay.
So the model has output X, Y, Z for this particular problem because of this type of customer profile, maybe. Yeah. So it's from that perspective that we use model building. So that's all really good. I think yeah. So once we have that model done, next we move on to the evaluation process, which is most of the time not A/B testing, but comparison with previous campaigns. So there is another bias that actually goes into the testing itself, because the previous campaigns need not be model based, could be business rule based. So you come up with solutions of testing your model results again, rule-based results as well. So you come up with a different combination of things, which would help in evaluating your model on real live campaigns. And another thing that we as a team will have to always look into is quick to deploy models, which means reusability of models for similar problems or similar products, so that you can keep your model usable for a very long time. At the same time, you are concentrating on your revenue generation aspect of it as well. And all of these without compromising on the customer experience, which is what it ultimately drives all of it. Model monitoring is very, it's been in the process for a few years now. Because of the data drift, we have the model drift, we have model metrics drift, and we have to counteract for all of that when you have a marketing campaign that is dependent on your model leads on a regular basis. So we have developed internal methods and again, I would say models to do that automated way. But at the end of the day, it's about revenue generation. So how do we go back and track the benefits that we have derived from the business using this model, or when the business is even testing this model for usage in the future? So that is a huge aspect of what we do in this machine learning process flow in the organization. Some of the different ways we track it is again tied back to the initial question setting or the problem statement setting. What are the different channels that we're going to concentrate? What are the different frequency that we are going to contact the client? And how are we going to get that feedback loop into our model process by itself? So once we have this sort of process streamlined and optimized from end to end, it becomes easy in terms of adoption by the business for different problems or different products, which are very similar in type within the wealth management space. So the key takeaway from what I want to share here is the bank of the future is all about personalization. You want the product that fits your requirement, at the same time satisfies the bank's requirement as well, a revenue or a business requirement as well. So keeping that in mind, the only way that we can go forward in terms of achieving to this point is analytics and technology, and specifically machine learning. I know we had some questions yesterday about using ChatGPT and the new language models that are available, or even other types of developing models. But how can we use these models in the different parts of the framework that I mentioned? Like, how can we make sure they are ethically correct? We are using the right privacy laws or the right privacy constraints that we need to look at, because at the end of the day, we are looking at the client interaction. We want to make sure that the customer goes away satisfied and the customer trusts us with their money and the data. So, so I would like to thank you all for your time here, and probably if you have any questions.